Welcome to our channel. Today, we're diving into the mind-bending world of science. We stand on the shores of the cosmic ocean, ready to dip our toes into waters that reflect not just the stars, but the very fabric of reality itself. For centuries, humanity has gazed upwards and inwards, seeking to understand the rules that govern our universe, from the grand dance of galaxies to the fleeting existence of subatomic particles. Each discovery peels back another layer, often revealing a picture more intricate, more bizarre, and more wonderful than we could have ever imagined. Prepare yourselves, because the journey we're about to embark on will challenge your perceptions and expand your horizons, inviting you to see the cosmos anew through a lens polished by relentless curiosity and the audacity of human intellect. The universe, it turns out, is a far stranger place than our everyday experience would lead us to believe. It's a realm where common sense can be a deceptive guide, where the rules that govern our macroscopic world dissolve into a symphony of probabilities and paradoxes at the quantum level. We're going to explore phenomena that sound like they've been plucked from the pages of science fiction, yet they are cornerstones of our current scientific understanding, tested and verified through rigorous experimentation. These aren't just abstract theories. They are fundamental aspects of the cosmos we inhabit, whispering secrets about the nature of space, time, and existence itself. They beckon us to question, to explore, and to marvel at the sheer ingenuity of the cosmic architecture that surrounds and includes us. So, buckle up your curiosity and open your mind. Get ready to have your brain broken by these 5 incredible scientific phenomena. We'll journey from the infinitesimally small to the cosmically vast, from the nature of light to the enigma of consciousness. Each stop on our tour will unveil a concept that has not only revolutionized physics, but has also forced us to reconsider our place in the grand, unfolding story of the universe. Are you ready to question everything you thought you knew, to embrace the discomfort of the unknown, and to emerge with a deeper appreciation for the mysteries that still await our understanding? Let's begin this extraordinary voyage into the heart of scientific wonder. Imagine 2 particles, forever linked in a way that defies our everyday intuition. This is quantum entanglement, a phenomenon so peculiar that Einstein dubbed it spooky action at a distance. It suggests a profound interconnectedness woven into the very fabric of reality. These particles remain in a shared state, their fates intertwined no matter the distance. One could be here, and its partner light years away. The astonishing aspect is their instantaneous connection. Measure one, and you instantly know the other's property. It's as if they are 2 aspects of a single, indivisible system. This challenges our classical understanding of cause and effect. Think of it like 2 specially prepared coins. You flip them, send one to a friend on Mars. When your friend observes their coin, you instantly know yours. With entangled particles, this knowledge is inherent in their shared quantum state. Before measurement, each particle exists in a cloud of probabilities, but the moment one is measured, its state is defined, and so is its distant partner's. This isn't just theoretical, it's been experimentally verified. Experiments have shown these spooky connections are real. They rule out simpler explanations like predetermined instructions. The universe appears to be non-local, with immediate influences across distances. The implications are staggering. Time. We experience it as a constant, an unwavering river flowing steadily from past to future. But what if I told you that this perception is an illusion? A local truth that breaks down under the extreme conditions of the cosmos. Albert Einstein revealed that time is not absolute. It's a flexible dimension, linked with space to form spacetime. This fabric can be stretched and warped, causing time to dilate. The faster you move through space, the slower you move through time. Imagine a spaceship rocketing away from Earth at close to the speed of light. For the astronauts on board, time would pass normally. They'd eat, sleep, and age as usual. But for observers back on Earth, their clocks would appear to be running in slow motion. If they returned after a few years, decades could have passed on Earth. This isn't science fiction, it's a consequence of the universe's speed limit, the speed of light. Nothing with mass can reach it, and as you approach it, bizarre things happen to space and time. This effect, known as time dilation due to velocity, has been experimentally verified. Muons, subatomic particles created when cosmic rays hit Earth's upper atmosphere, are a perfect example. They have a very short lifespan, yet we detect them at ground level in far greater numbers than classical physics would predict. Why? because they are traveling so fast that their internal clocks slow down relative to us, allowing them to survive the journey. But it's not just speed that affects time, gravity does too. Einstein's general theory of relativity a decade later painted an even more radical picture. Gravity is not a force, but a curvature of space-time caused by mass and energy. The more massive an object, the more it warps space-time around it, and the slower time flows in its vicinity. This means that your feet, being slightly closer to the Earth's center of mass than your head, are aging infinitesimally slower than your head. The difference is minuscule, but it's real. For more dramatic effects, we need to look at objects with immense gravity like black holes. Prepare to enter a realm where the very act of looking changes what you see. The double-slit experiment reveals the baffling dual nature of matter and light. Electrons, photons, and even atoms can behave as both particles and waves. Richard Feynman said it contains the only mystery of quantum mechanics. When observed, particles behave predictably, but unobserved, they explore all paths like waves. Observation changes the outcome, collapsing the wave function. Imagine a cat, a flask of poison, and a radioactive atom, all sealed together in a steel box, completely isolated from the outside world. This isn't the setup for a macabre experiment, but a famous thought experiment devised by physicist Erwin Schrödinger in 1935. Its purpose? To highlight the sheer absurdity, or at least the profound counterintuitiveness, that arises when quantum mechanical principles, which govern the microscopic world, are applied to macroscopic objects like a cat. The setup is ingenious in its cruelty, metaphorically speaking. The radioactive atom has a 50% chance of decaying within a certain time, say 1 hour. If it decays, it triggers a Geiger counter, which in turn releases a hammer that smashes the flask of poison, killing the cat. If the atom doesn't decay, the cat remains alive. According to classical intuition, after 1 hour, the cat is either definitively alive or definitively dead. We just don't know which until we open the box. But quantum mechanics paints a far stranger picture. Until the box is opened and an observation is made, the radioactive atom is said to exist in a superposition of states. It has both decayed and not decayed simultaneously. And if the atom's state is linked to the cat's fate, then, by extension, the cat itself must also be in a superposition. It is, according to a literal interpretation of quantum formalism for the system as a whole, both alive and dead at the same time. This is the paradox of Schrödinger's cat. It takes the fuzzy, probabilistic nature of the quantum world and scales it up to an everyday object, forcing us to confront what superposition truly implies. Can a cat really be in such an indeterminate state? Our experience tells us no. Cats are either alive or dead, not some ghostly blend of both. This highlights the measurement problem in quantum mechanics. What constitutes a measurement that collapses the superposition into a definite state? Is it the Geiger counter, the cat itself, or the conscious observer opening the box? Schrödinger designed this thought experiment not to suggest that cats can actually be simultaneously alive and dead, but to question the completeness and interpretation of quantum mechanics when applied to systems beyond the subatomic. We often think of observation as a passive act. We look at a mountain, a star, or a friend, and we assume that our gaze doesn't alter the thing being observed. In our everyday macroscopic world, this is largely true. The light bouncing off a mountain and entering our eyes has a negligible effect on the mountain itself. But journey with me into the quantum realm, the world of atoms and their constituents, and this comfortable assumption shatters. Here, the very act of observing a phenomenon can fundamentally change its outcome. This is the observer effect. It's crucial to distinguish the observer effect in quantum mechanics from the more general idea that any measurement can disturb a system. For instance, measuring tire pressure inevitably lets a little air out. That's a classical disturbance. The quantum observer effect is far more profound and intrinsic. It's not just about a clumsy measurement, it's about an inherent interconnectedness between the observer, or the measurement apparatus, and the observed system, where the properties of the system are not well defined until a measurement is made. We saw a striking example of this in the double-slit experiment. When we don't try to determine which slit an electron passes through, it behaves like a wave, creating an interference pattern. But the moment we set up a detector to find out which slit it chose, the wave behavior vanishes and the electron acts like a particle going through one slit or the other. The act of looking for which path information forces the electron to choose a path, thereby destroying the superposition that allowed for wave-like interference. This isn't about consciousness in the mystical sense, despite some popular misinterpretations. The observer doesn't need to be a human being or even a sentient entity. Any interaction with a measuring device that extracts information about a particular property of the quantum system can collapse the wave function, forcing the system out of its superposition of states and into a single definite state corresponding to the measured property. A Geiger counter, a photodetector, even an air molecule bumping into a quantum particle can act as an observer in this context. The observer effect highlights a fundamental feature of quantum reality. Properties of quantum systems are often not pre-existing and definite before measurement. And there you have it, 5 glimpses into the astonishing, often paradoxical nature of our universe as revealed by science. From the spooky interconnectedness of entangled particles to the flexible nature of time, from the dual personality of matter to the profound role of observation, these phenomena challenge our everyday intuition and expand our cosmic perspective. They remind us that the universe is not only stranger than we imagine, it is stranger than we can imagine with our classical, macroscopic minds. Yet, through the rigorous application of the scientific method, through curiosity and perseverance, we continue to peel back its layers, revealing an ever deeper, more intricate, and ultimately more beautiful reality. These discoveries are not endpoints, but gateways to further questions, further exploration. Each answer uncovers a dozen new mysteries, beckoning us towards an ever-expanding frontier of knowledge. The journey of science is a testament to the human spirit's relentless desire to understand, to make sense of our existence, and our place in the vast cosmic tapestry. It's a journey fueled by wonder, a journey that transforms us as much as it transforms our understanding of the universe. The cosmos is rich with such wonders, waiting for curious minds to uncover them. Thanks for watching. If you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-blowing content. We're dedicated to exploring the frontiers of science and sharing the awe-inspiring discoveries that shape our understanding of everything. Let us know in the comments which scientific phenomenon blew your mind the most. Was it the instantaneous connection of entanglement, the warping of time, the peekaboo game of the double slit, the paradoxical life of Schrödinger's cat, or the universe's response to being watched? Join the conversation and keep looking up.